Good evening, students. This is common gate analysis, small signal analysis of common gate amplifier. Listen, small signal analysis of common gate amplifier of FET BJT. என்ன FET BJT என்ன சொல்றேன்னு பார்த்தீங்கன்னா, just this is the symbol of FET. Okay, this is the symbol of FET. உங்களுக்கு JFET கொடுத்தாங்கன்னா இது அப்படியே போடுங்க. MOSFET கொடுத்தாங்கன்னா instead of JFET symbol, just you draw the MOSFET symbol. Entire thing will be same. Okay. The one question is for two devices. அதாவது கேட் சிம்பிள் இத என்ன சொல்றேன்னா JFET போட்டா நீங்க இந்த சிம்பிள் போட்டா போதும். ஓகேவா? MOSFET போட்டா என்ன பண்ணணும்? MOSFET ஓட சிம்பிள் போட்டீங்கன்னா போதும். மத்தபடி எல்லாமே சேம் தான். ரைட்? ஓகே. Now, so இப்போ நம்மளோட கொஸ்டின் என்ன? Small signal analysis of JFET amplifier. Instead of JFET means you put JFET symbol, that is JFET. You put MOSFET symbol, it's called as MOSFET. Okay, right. Now, so in this symbol, okay, listen here, this is source, this is source resistor. So don't confuse in the source resistor in the source in the source resistor confuse agakudadu because this resistor is indicated as small rs. Okay, right. Then அப்ப இது என்ன ரெசிஸ்டன்ஸ் பாத்தீங்கன்னா this is the resistance of this source. Okay, right. இப்போ புரியும் நினைக்கிறேன். This resistance is in the source itself. Source விட்டு வெளியே வராது. Source உள்ளேயே இருக்கக்கூடிய resistance. அந்த resistance என்ன பண்றோம் உங்களுக்காக வெளியே போட்டு காமிச்சிருக்கேன். Are you clear? Okay. You add the resistance or remove the resistance. There is no problem of this resistance because the resistance value is very, very, very low. It's not external to the device. It is inside the device. Okay, right. Then what is this capacitor? What is this capacitor? These capacitors are called as input capacitor. This is called as output capacitors. Okay, right. Then what is resistor? This is rs, source irukliya. That's why inga enna resistance irukum? Source resistance. This is drain. So appo inga enna resistance irukum? This resistance is called as drain resistance. So இப்போ உங்களுக்கு clear-ஆ புரியும் நினைக்கிறேன். Right. So source, this is source, resistance is source resistance, this is drain, so resistance is drain resistance. Okay, this is VGG, gate voltage. Okay, output, normally output is V0. So இப்போ என்ன பண்ணலாம்? This is V0. Suppose உங்களுக்கு எனக்கு இல்ல இது V0 வேணாம்னு சொன்னா என்ன பண்ணலாம்? V out கூட போட்டுங்க because output na output. So this is R0 போடலாம். R0 means output resistance or RL கூட போடுங்க. That is RL means load resistance. R0, RL எது வேணாலும் போடலாம். Okay, this is your source resistance, this is your drain resistance, this is your load resistance, this is your output. So what is output? V0 is equal to the current flow through this resistor is I0, no? So I0 is nothing but ID, right? இங்க என்ன resistance இருக்கும்? இங்க என்ன current இருக்கும்? This current is ID. அப்ப அந்த current எங்க வருது? இந்த resistance வழியா வரும். So V0 is equal to ID into R0. Right, anyway. Then this current is directly going through the source, no? So that's why there some current is in the source, no? That is called as IS. This source current is equal to drain current. IS is equal to ID because இங்க இருக்க current தான் எங்க போகுது? இங்க போகுது இல்லையா? This current is going through this side. So it is called as, this is called as IS, this is called as ID. IS is equal to ID. You know that ID is equal to GM into VGS. நம்மளுக்கு எல்லாம் தெரியும் இல்லையா? ID ஓட வேல்யூ என்ன? நிறைய பார்த்திருக்கோம். இந்த small signal analysis. I is equal to GM into VGS. I is equal to V by R. Correct? This is Ohm's law. I is equal to V by R. What is the R? R is nothing but 1 by R. அப்போ 1 by R என்ன பண்றாங்க? GM அப்படின்னு போட்டுக்கிறாங்க. Okay. R is G 1 by R equal to GM. This is equal to கூட போட்டுக்கலாம் ரைட்டா. ஸோ இங்க என்ன பண்றோம், this what is this, Ohm's law. Ohm's law is equal to V by R. What is V? V அப்படியே போட்டாச்சு. ஓகே, வோல்டேஜ் மாற போறது கிடையாது. தென் R 1 by R is nothing but GM. So GM into VGS அதான் இங்க வந்திருக்கு. ID is equal to, அப்ப என்ன பண்ணுது கரண்ட் ID ன்னு போட்டுக்கலாம் இல்லையா. This is ID is equal to GM into what is this, source and drain. So gate and source VGS. இதுதான் என்ன வருது, ID is equal to GM into VGS பாறோம். Anyway, this explanation is not necessary for your understanding. உங்களுக்கு புரியறதுக்கு நான் சொன்னேன். So ID is equal to GM into VGS. Are you clear? Right. Now we go to next level. Now listen here. So this is the circuit. This is the circuit. You know that our source, drain, gate. This is source resistor. This is source. This is drain. Then what is this? Source resistor. This is your RD, drain resistor. This is your R naught or RL. R naught na output resistance. RL means load resistance. Anyway, so listen here. In the source drain irukku. Normally the source is, that is the FET device is normally we draw the small signal model of this device. What is a small signal model? ஒண்ணுமே இல்லப்பா, just a small signal model means ஒரு current இருக்கும், ஒரு resistance இருக்கும், வேற எதுவுமே கிடையாது. Whatever may be the device, it's a transistor, MOSFET, GATE, what is this, whatever may be the device, ஒரு current இருக்கும். It have one current and one resistor. வேற நீங்க கன்ஃபியூஸ் ஆக வேண்டிய அவசியமே கிடையாது. ஒரு டிவைஸ் பாத்தீங்க என்ன பண்ணீங்க, ஜஸ்ட் ஒரு கரண்ட் ஒரு ரெசிஸ்டர் போட்டுக்கோ. கரண்ட் அண்ட் ரெசிஸ்டர் ஆர் இன் parallel. So this is common for everything, right? Okay. Now instead of JFET, this is JFET. Then you put a you change the symbol into MOSFET also. நீங்க என்ன பண்ணலாம், symbol change பண்ணிக்கலாம். Anyway, the same தான். GM into VGS. Here is RD. Now same thing. Drain resistance. Then this is source resistance. So this is source, no? This is source resistance, right? This is your drain resistance. This is drain output resistance. So input voltage, everything will be there, right? Everything is there. Okay. Now see here. அவங்க என்ன பண்ணாங்க, they notate this is ZI, ZS, Z0, ZD, Z0 அப்படின்னு போட்டுருக்காங்க. So listen, நம்ம என்ன பண்றோம், இதுக்கு முன்னாடி impedance means we classified into input impedance and input impedance and output impedance. Input impedance for source and input impedance for symbol device and circuit. Output impedance for device and circuit அப்படினு போட்டுப்போம் இல்லையா. இவங்க என்ன பண்ணாங்க, கொஞ்சம் நோட்டேஷன் மாத்திருக்காங்க. எனிவே நீங்க என்ன நோட்டேஷன் வேணா போடலாம், பட் just clearly indicate what is this. ZI means circuit input impedance. நம்ம என்ன போட்டுப்போம், ZC போட்டுப்போம் இல்லையா, ZIC போட்டுருப்போம். இங்க என்ன பண்ணாங்க, ZI போட்டாங்க, circuit impedance. ZS நம்ம என்ன பண்றோம், we put this is ZD போட்டுருப்போம் இதுக்கு முன்னாடி. Okay, ZS device input impedance, Z0 output impedance, ZD device ஓட output impedance. Anyway, just whatever may be, you put A, B, C, D, whatever may be, but என்ன பண்ணோம், இங்க represent பண்ணா போதும். So don't confuse. இதுதான் வந்து இதுதான் என்ன சொல்றது, this is the formula, this is the format அப்படின்னு சொல்லி பார்க்காதீங்க. They assume, ஓகேவா, நீங்க என்ன வேணா அசியூம் பண்ணிக்கலாம், பட் என்ன பண்ண இடத்துல இதை வந்து இண்டிகேட் பண்ணிடணும். ஓகே, ரைட். தென் சேம் திங் மா, வேற ஒண்ணுமே இல்ல. ஸோ ZI இன்புட் இம்பிடன்ஸ், ZG, தென் ZD, ZO எல்லாமே என்ன பண்ணுது இங்க போட்டாச்சு. தென் வாட் இஸ் திஸ் ZS னா டிவைஸோட இன்புட் இம்பிடன்ஸ் அப்படின்னு நம்ம போட்டிருப்போம், ரைட்டா? ஓகே. நவ் இப்போ என்ன பண்றேன், இந்த இடத்துல Z இம்பிடன்ஸ் கண்டுபிடிக்க போறோம் இல்லையா. ஸோ ZS, that is input impedance. What happened? Input voltage by input current. What is input voltage? This ZS is equal to input resistance. Input impedance is equal to what happened? Input voltage divided by input current. This is your input voltage. This is your input current. Why input voltage என்ன பண்ணுவோம், VI input இல்லையா. That's this I indicate input. Here also this and I indicate input current. Anyway, VI by IA. Now what is this VI? VI is equal to VGS. VI is equal to VGS. What is the current in the input? The current is nothing but ID, because the current இங்க இந்த current எங்க போகுது, இது இப்படி தான் போகுது இல்லையா. So input also, what is the current? ID. IS னு போடலாம். IS is equal to ID. Right. Now listen. So you know the value of VI. VI is equal to VGS. You know the value of II. What is II means? IS போடுங்க. IS is equal to ID. Now what is ID? ID is equal to GM into VGS. So என்ன பண்றேன், I'm substituting VA is equal to VGS. ரொம்ப மக்க பண்ண வேண்டிய அவசியம் கிடையாது. VA. Then what is the next one? ID. You know the value of ID. What is ID? ID is equal to actually the input என்னது IS. Now IS is equal to ID இல்லையா? That's why IS எடுத்தாச்சு. Then what I do? Just I draw the ID. ID. Okay. So ID is equal to, what is ID? You know, ID is equal to G M into V G S. Now listen here. Normally here it is the VGS. This is your VGS. Oh, what is the ZS? ZS அவங்க input impedance ZS கொடுத்துறாங்க இல்லையா? Anyway, so ZS is equal to என்ன வரும்? எல்லாமே cancel. Everything will be cancelled. Only we get 1 by GM. 1 by GM. So listen here. நிறைய பேர் மறந்து போகுது சொன்னீங்க. That's why I'm indicate everything in the circuit itself. There is no mug up, right? So Z is equal to 1 by GM. இப்படி இருக்கான்னு மட்டும் நம்ம பார்த்துக்கலாம். ஓகேவா? So listen here. This is Z. Z is equal to VGS. Why is minus? This is the opposite direction. No, current is in the opposite direction. Then II. What is II? GM into VGS. So minus minus cancel. Finally we got GM. Then what is circuit impedance? Always I told circuit impedance means just you add any of the sources, any of the resistance. முன்னாடி என்ன இது R1 R2 whatever with resistance is there, just you add, that is your circuit resistance. இது நம்ம என்ன பண்ணலாம், இப்படியே எழுதலாம், that is ZI போடுறாங்க இல்லையா? Anyway, so circuit resistance ZIC ன்னு சொல்லுவோம்ல, அப்படி போட்டுதானே போடுவோம். Okay, ZIC input circuit resistance is equal to 1 by GM parallel RS. Okay, so what is 1 by GM? 1 by GM is equal to Z இல்லையா? So என்ன பண்ணாங்க, they put instead of 1 by GM they put Z, then circuit resistance RS. That's all. Everything will be over. Input device impedance is over, circuit impedance is over. Okay, now we see the output side, right? So see here. So now we see the output side. Now listen, output side means you find out the output. Assume input is equal to 0. There is no input. அதான் நான் ஃபர்ஸ்டே சொல்லியிருப்பேன். நார்மலா யூ ஹேவ் ஒரு காரை தள்ளிட்டு போறீங்க வச்சுங்களேன், ஒரு 4 மெம்பர்ஸ் என்ன பண்ணாங்க, அவங்க கூட சேர்ந்து காரை தள்ளுறாங்க, ரைட்? தே ஆர் ஹெல்பிங் யூ. யாருமே இப்போ ஹெல்ப் பண்ணல. அப்பதான் என்ன, இந்த காரோட ஒரிஜினல் லோடு எவ்வளவு தெரியும். ஓகே, ஸோ டு ஃபைண்ட் அவுட் த எக்ஸாக்ட் லோட் ஆஃப் த கார், விச் டைம் no one will help means that time you understand, no? So there is no input will be 0. That time you know the exact load. Now listen, this resistance and this resistance are in parallel. What is சொல்லுவாங்க, இது என்ன சீரிஸ் தானே இது அப்படினு? Nothing. ஒரு ரெசிஸ்டன்ஸ் இருக்கு இல்லையா? Listen here, this is one resistance, the basic concept தெரியல தெரிஞ்சுங்க. Resistance is there, here also one resistance is there. Now என்ன பண்றாங்க, they combine this end and this end and this end and this end. So if we combine the two resistors are in parallel. So this resistance RD is device resistance. RD, this is present inside the device. This also RD, this present outside the device. புரியுதா? This RD is present inside the device, this RD is present outside the device. Okay, anyway, the same thing, RD parallel RD. The RD, this value is very very high. Normally in parallel, what we do, highest தான் எடுத்துப்போம் இல்லையா? highest என்ன பண்றோம், நெகல் பண்ணிட்டு this is your RD. ஒன்னும் இல்ல, இது சின்ன ஒரு கான்செப்ட். Listen here, 2, first resistor is 2, second resistor is 6. Then what is the output resistance? 2 into 6, R1 into R2. Okay, 2 into 6 divided by 2 plus 6. 2 plus 6. What is the answer? 2 into 6 is 12. 2 plus 6 is 8. 2 into 6 are 12. Then 2 plus 6 is 8. Now what happened? This value will be much higher, no? That's why we are removing the highest. This value will be very very low. That's why we are removing the highest value of resistance. Here also RD is high, this RD is very very low. That's why we are rejecting this RD. We put Z0 is equal RD. So இப்போ என்னாச்சு output impedance முடிஞ்சாச்சு. Okay, Z is equal to RD, right? Output impedance is over. Finally what we do? Finally what we do? Just voltage gain. What is voltage gain? V naught, output voltage divided by input voltage. What is output voltage? V naught is equal to ID, that is the output current. Then what is the resistance is present in the output? Just you put entire resistance. So you find out the V naught. Then what is ID? This ID. What is ID? ID is equal to, GM into VGS. Okay. Now substitute this value of ID here. Listen. 2 minutes. Okay. So your ID value. Now what I do means, just I'm substituting this value here. Now I find out the V naught. Are you clear? Find out the V naught. Then circuit. Circuit means just you add. So listen here, V naught by VA. What is V naught? You know the value of V naught. This is your V naught. Then what is your VA? VA is equal to VGS. So entire thing will be cancelled. This VGS and this VGS has cancelled. This is your GM. This is your RD. This is your RL. So GM is RD parallel RL. Right? So entire thing will be over. Since the voltage gain is positive, yeah, anyway. So this is the entire thing, overall idea. That is to find out small signal analysis of JFET or MOSFET, whatever it may be. JFET means you write the JFET symbol. MOSFET means you draw the MOSFET symbol. Right? Okay. Then in this you find out two: input impedance and output impedance. Input impedance for circuit and device. Output impedance for circuit and device. Here also we have find out the input impedance for device and circuit, output impedance for device and circuit. Finally we find out the AV. AV is nothing but A. A is nothing but A means gain. Here it is the voltage, no? So voltage gain AV. AV is equal to V naught by VI. Previously we find out the V naught value as well as VI value. So V naught value means don't worry about V naught value. Just whatever may be voltage gain வரும்போது அதுக்கு முன்னாடி V naught value என்ன கண்டுபிடிச்சாலும் என்ன பண்ணுங்க, V naught is equal to output voltage into output current. That's all. Output voltage is ID. Output voltage is, what is output voltage? ID. That is GM into VGS. Here, that's all. So you got a voltage gain, right? So whatever may be this is a common source, common drain, common gate, whatever it may be, V naught. In this stage, V naught means I into R. Just to simply write, okay, I into R. Then this also some drawback. Drawback means due to load, input load impedance, that is low. Input impedance is low, right? So input impedance is low means what happened? The entire thing, noise also will come, right? So that's why this is the important thing in this. What is this? Small signal analysis of common gate FET or MOSFET. FET na, you draw the FET symbol. If it is MOSFET, you draw the MOSFET symbol. Anyway, thanks for listening. Thanks for watching. Thank you. Yeah.